Alright, here's my PA3 code. Now, this program took a while to make actually. Most of the time was spent trying to think of what physics to actually use. And considering I've never actually taken a physics class in my life, it was kind of a hands-on way to learn all that stuff. So eventually, after messing around with it for a while on Saturday, like the whole day, I realized like that you don't have to do it with angles, so to speak. You can just do it with um, horizontal velocity and vertical velocity, and these two that velocity with directions is actually really simple. It's actually only two lines of code, and that pretty much gives you parabolic motion, or how the hell do you say that name? So anyway, I have four classes: the game model, a square, a disk, and a joule. So basically, I'll go to disk. This is kind of the main class because it's kind of what you're going to be throwing. So like, I'll just scroll over. Yeah. So I pretty much have fields. I have in my constructor. I take like initial, um, basically x and y values, the vertical velocity which you specify, and the horizontal velocity. Pretty simple accessor mutator methods. Square, pretty much just with initial x, initial y, joule, pretty much just extend square. So that's that. Now everything else is really in disk. Now the way I have disk set up is, no, not disk, model, sorry. So model is where I have most of my code, I would say. It's kind of my main class that has a lot of stuff. So first of all, I have gravity at negative 9.8. It is a global constant. I have a counter. I've been using this. This is actually really handy. I've been using this. I saw that Tim has a debuggable boolean. So I actually in my code, like I have all these if statements when debugable equals true, run this, and it's actually really handy, and it's a lot easier than going through and getting rid of the stupid slash marks or whatever. So yeah, I didn't make a level because I didn't really think you needed one, at least for what we were testing now. Um, so basically what I did is I declare a location of joules, I declare a location of disks, and I declare a location of squares. Now, what it is I give the location a point, and I declare the radius, and in the case of disks, I declare their initial vertical velocity and initial horizontal velocity. So I do all that, and I use lists. So I add all the disks to a disk list, and that's the list that you start out with a disk. There's a static disk list that contains all the disks that have already been played, the joule list, which has all the joules, and the square list, which has all the squares. So what happens is that basically the game loop is here. While disk list is empty equals false, basically while you still have disks, fling that disk, and if you by the time you're done with that loop, you win or lose depending on if you basically hit all the joules. It'll remove that joule from the joule list, so it'll say you win, otherwise you lose. Fairly simple, right? So yeah, um, let's run it. So yeah, I have it so the debuggable is turned off, so I just see what you'd see in the game. So firing this number one. This number one hit a joule. Nice. Firing this number two. This number two hit a square. Firing this number three. This number three hit a joule. Nice. Firing this number four. This number four hit the floor. Firing this number five. This number five hit a static disk. You win. You win because you've pretty much removed all the joules. Now how does that work? It works in a way that like I go through my loop, I check if, yeah, I basically have check use the is collidables. That's how I did it. Yeah, I had two intersect methods. I had intersect for disk to disk, and I had intersect for disk to square. Disk to square was a lot more complicated because I basically had to account for corners too. And basically I check if they collide with each other. And if they do, I basically say they do, and that pretty much takes care of that. Also, for time, I could have used real time, but to make it simpler, I just used a for loop with t that goes up and down. And I suppose you might want to see some actual coordinates. I did that. I'll do that now. I'll just make debuggable true, and we'll run it again. So this is what it looked like most of the time while testing. I have this interface of static disks true, false, false, false. As you can see, it stays true because that's like one of my check statements. And you go back, you can see some points. Basically, when it does hit something, if the disk becomes static and it pretty much doesn't move. So yeah, if you want to see more, you can look on my code at GitHub, but that's all I'm going to say. I'm not going to keep you any further. Thank you very much for listening, and have a good day. Bye.